Okay, so thank you for coming. Right, we got a lot to cover. So if I missed today's lesson, it was gonna be very bad, right? So I don't think anybody else is coming. So we covered we are differential, then limits and differentiation. I'm on page 198. So we've done limits, right? We've done binomial theorem. We've done differentiation of first principle, and we've done differentiation, right, using short methods. So I'm on page 188, and I'm now at the chain rule. Okay?
So in this sense, we always can say false is no.
Please, right? Because if I get this chain rule, quotient rule, and product rule done today, tomorrow I can do graphs, and then we can finish earlier next week with maths, and then we can start doing past papers, right? Okay. So I'm on the chain rule, page 188. So the 15 rules that was given in 6.4.3. Remember that 15 rules for differentiation. For calculating standard differential coefficients have many restrictions. For example, they cannot be applied to functions of functions. Do you understand what they mean by functions of functions? Okay. See, an example of a function is x squared. Right? So I'll call this f of x. Right? Another example of a function is x plus 2. Right? So this is a function of x. X is your independent variable. Now what happens if you have x plus 2 all squared? If this was in this. Get what I'm saying, right? It's a function of a function because this inside portion squared is one function. That inside portion is another function. Right? So you can't just apply the rules that we had before was very straightforward. If it was x to the power n, or if it was ln of x, or if it was whichever rules that we were looking at, right? E to the power x. Still, it's one function. Right? But when you have something like this, it's a function of a function. That's why remember when we were doing that one and that last part never come right. It's because we couldn't apply those rules because they were functions of a function. Okay? So, if we carry on, right? Closer examination shows that the rules are only valid for x. Right? If we change x even to negative x, then we are dealing with functions of functions. So that part is very important, right? It's only valid for values of x, right? Those 15 rules before. Even if we have negative x, so if we had, for example, 2 sine x, right? What's your function there? The function is like f of x would be sine of x, right? That's the function. You put it there, we would have got, because if we did the differential of this, it would have been d over dx 2 sine x. 2 is a constant, so it would have came out, you would have had d over dx sine of x, and then you go and you can differentiate. It's only in terms of x. But if I told you sine of 2x, that's a different thing. This is sine of x times 2. Okay? So when you're doing the differential of it, d over dx sine of 2x, it's not the same as, and this would have came out to 2 cos x, because the differential of sine x is cos x. That is not the same thing. Right? Sine x is one function. 2x is another function. This is a function of a function. You understand the concept, right? Okay. So, dealing with function instead of just functions, and to differentiate functions of functions, we need new formula. They tell you that functions that can be calculated using rules 1 to 15 in 6.43. If you have x to the power n, it's only in terms of x, right? You can use the rules. But if you had 2x plus 3 to the power n, that's a function of a function. You need new rules, right? If you have e to the power x, that's just one function, which is x. If you have e to the minus x, e to the 2x, e to the x squared, those are functions of a function. Similar for all these other stuff that they give you. Right? We get familiar with how these functions or functions look. So when you're doing it in a test or exam, you know when you identify it, you can't just use the straight rules like how we used it now. Okay? So we get something called the definition of a chain rule. We get something called the chain rule. Okay? So the chain rule is what we will use to calculate derivatives for the function of a function. So far guys, you're with me, right? Okay.
Yeah.
So if y is a function of u and u is a function of x, then the formula for chain rule is dy over dx is equal to dy over du times du over dx. So the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. Okay, you understand how I said this, right? I'm gonna come to that, right? But you understand the concept of what I'm saying. Derivative of y with respect to x. Derivative of y with respect to u. Derivative of u with respect to x. Okay? Right. You do not need to know how to prove this formula, so I'm not going to go to the proof with you because I don't want to give you unnecessary tests and all that. Right? So the main thing you need to know is chain rule looks like this. This is the chain rule. Okay? So I'm going to move on to application of the chain rule. This rule, I'm on page 200, right? This rule can be applied to all functions of function. Then we know what a function of a function is now. Okay? So it is if f of x is to the power n, if you have a function to the power n, where n is not equal to 0 and n is not equal to 1. For example, if you have x to the power 4 plus x, x to the power 4 plus x is a function. That bracket to the power 4 is another function. Or 6, right, is another function. Sine cubed x, right, is sine x cubed. That's a function. One function is sine x. That bracket cubed is another function. Okay? Similarly for the other stuff. A to the power f of x. That's why, you know, earlier when they gave us, I think they had 4 to the power minus 2x or something like that. Right? 4 to the power x is one function. Right? Minus 2x is another function. Okay? It's not just x. Those first 15 rules are only valid for x if it's just x. You can understand that? Okay? Or x or any other variable name, right? So that's why a to the power f of x would have been what we should have used. Okay? Similarly for all these other stuff. Now all of this theory will only make sense once you do an example. Okay? So let's do the example that they have over there. They say calculate dy over dx if y is equal to 2x. Y is equal to 2x. This is what we have. Right? You understand the concept that one function is e to the x and the other function is 2x. Those are two different functions. Okay? I know I'm using x twice over there, but I'm just going to call it that. We'll see on a great example. So how you would solve this? You would say, let u equal to 2x. You let it equal to the function that has x in it. Okay? Important to remember. Let it equal to the function that has x in it. Why you let it equal to the function that has x in it? Because remember when we're getting this part here, we are deriving equation u with respect to x. Meaning that when you derive that equation, you should end up with terms that have x in it. So the equation that you would choose should be the equation that has x in it. Because you're going to derive like that. And with me there? Yeah. Once you do this, you derive equation u with respect to x. Because, so when you're saying d of u with respect to x, you're deriving the equation with respect to the independent variable. Your independent variable here is what?
X.
It's x, right? Because u is dependent on the value of x.
Mm-hmm.
X is independent. So we're deriving equation u with respect to your independent variable, which is
X.
x, right? So on this end here, you will also introduce d over dx, okay? And that will be for 2x. We're all together here.
Yeah.
Anybody? Which part?
First part.
Here. Yeah. Okay. So I let u equal to 2x. You understand that part, right? And then I'm going to derive it. So I'm deriving equation u with respect to the independent variable. So I derive equation u with respect to x. And then because I introduced d over dx on this side, I have to introduce it. Huh?
Similar to the
Like how we did the differentiation, like how we did it normally, right? So that's why the concept is very important, right? And you all got it, so I know you'll understand it, right? So this is du over dx is equal to. Now this is differentiation of one function, right? We can agree on that. Because this would become 2 because it's a constant. D over dx x. And the derivative of this from our earlier rules, if you look, I think it was rule 1, right? It will be n times x to the power n minus 1. It will be 1x to the power 1 minus 1, which is x to the power 0, which will make it 1, right? So you're only left with the constant, okay? So du over dx is equal to, no? It's not equal to 1, 2. It's equal to 2. So that's what du over dx is equal to. Okay? Because we let u equal to 2x, right? So if u is equal to 2x, this implies that y is equal to e to the power u. With me? Okay? Because I just called u 2x u, so I replaced the 2x here with u. Okay? Now what's my independent variable? Remember e is a constant, e is a number, e is 2.6 something. So it's 2 to the power u, like 2.6 something something to the power u, right? What is your independent variable?
It's the U.
It's the u. You understand that part, right? Because y is dependent on the value of u. E to the power 1 would give you a value of 1. E to the power 2 would give you a value. Y's value is dependent on the value of u, which makes u the independent variable. So when you're differentiating, we are differentiating equation y with respect to
Du.
du, your independent variable. So on this end, you will differentiate with respect to u of e, u. You understand? Like how here, x was your independent variable. So we'll differentiate equation u with respect to terms of x. Here, I'm differentiating equation y with respect to terms of u. Because u is your independent variable. Are y'all with me?
So we just went from x to u.
Yeah, because that's why I keep on saying dependent and independent. I don't want to keep on using x because if I use x and you'll see other factors, you're only in your head, you're only going to think x. Okay? So this here is basically dy all over du equal to. If you look at this and you go to your rules, right? Which one does that look like? Which rule number?
What's this 5? E to the power what?
X.
Where's that one?
It's that one, right? Don't be confused with the fact that that only has it in terms of x. X is the easiest variable that we use, right? It could be e to the power a, b, c, d, all the way up to z, right? Whichever letter they use. Irrespective, it's still the same concept, right? So the derivative of e to the u is e to the u, right? It will be e to the u. So now we have du over dx, dy over du. So you apply a chain rule, okay? your chain rule says that dy over dx is equal to dy over du times du over dx. dy over du is e to the u times du over dx is 2. So your answer is 2eu. So no, sorry, that's not your answer. You can't leave it in u because you're deriving y with respect to x. So your equation should come out with terms that have x in it. So what you will do is you will say dy over dx is equal to 2e to the power 2x because you let u equal to 2x. And that is the derivative of e to the power 2x.
Sure.
Do we understand what I did? Okay, quick summary of what I did. This was my equation that was given to us. They wanted us to derive it. By looking at it, we identified that it's a function of a function. Why? Because it's not just x. Okay, so we identified that. Now we know it's a function of a function. Chain rule. Okay, for chain rule, you need to have the derivatives of u as well. So you would let a function, one of those functions, equal to u. Which function would you let equal to u? You will let the function that has the independent variable of x. So we let u equal to 2x. Okay? Then I derived equation u with respect to x. And I got a value of 2. du over dx is equal to 2. Because I let u equal to 2x, my equation y became y is equal to e to the power u. We understand, right? Now my independent variable is u. So now I derived equation y with respect to u, factors of terms of u. Okay? And I got dy over du equal to e to the power u. Chain rule states that dy over dx is equal to dy over du times du over dx. Okay? So I substituted because I have the values of it. And I got this equation 2e to the power u. Because I said u is equal to 2x, I'm going to substitute it back. Why I substitute it back is because I'm deriving y in terms of x, not in terms of u. That is the answer. Okay? It's first time reading, but you'll understand the steps that was involved in it.
Yeah.
Anybody confused about anything? Sure, right? Okay. I'm going to do a few more examples. Main thing is that first 3 examples you do, if you understand the concept, then the next parts I do is going to be very easy for you. Right? Okay. Can I take a look?
Yeah.
Yeah.
So now let's do another example where they tell you y is equal to 2 to the power minus x. Okay? That's what they gave us. So are you able to identify what are our 2 functions that's there? What's your 2 functions?
2x and minus x.
Minus x there. So you understand. Minus x is in that spot of where x would have been. So that's our 2 functions. Okay? So now that we identified it, to derive it, you're going to need to use the chain rule because it's a function of a function. Okay? So what did I tell you all first? When you're starting it, you need to let something equal to u. What is the something that you let equal to u?
Independent variable x.
Right? The function that has the independent variable of x. In that instance, it would be minus x. So you would say let u equal to minus x, and you derive. Now we're deriving equation u with respect to x. So I introduce d over dx on this side, I have to introduce it on that side. So d over dx minus x. Okay? So du over dx is equal to, remember that's a minus 1. It's a constant. So you take it out. Minus 1 d over dx of x. d over dx of x is what? 1, right? Because it will be 1 times x to the power 1 minus 1, which is x to the power 0. X to the power 0 is 1. Okay? So du over dx is equal to 1. Cool. Right?
Okay, so
the sign changed now?
Sorry.
okay, so we have to remember that in this one we are applying rule 1 from the 15 rules in the step.
In this one, yeah. So okay, so because remember it's in terms of just x, so we can use our earlier rules, and you're going to have to, right? You break it up to try and use your earlier rule to make it simpler. Okay, now that so if u is equal to minus x, this implies that y is equal to 2 to the power u. Okay, so now let's derive y, equation y, in terms of, or with respect to u, because u is your independent variable. So dy over dx is equal to du is equal to d over du 2 to the power u. Okay? Okay. D over du. Too many D's in this thing, right? I'm getting in the game, I'm here. Sorry, right, yeah. Now go back to your roots. It's with respect to one variable. So we can go back to our rule 115. Which one looks like this? Which one has a value to the power of something? A value to the power of x. It may look like a to the power of x. The derivative?
6.
Number 6.
Yeah.
Number 6 says d over dx of a to the power x is equal to ln of
A.
a. Yes?
Yeah.
Okay. So this would become, agreed? Actually, Tampa, you lied to me. It's actually a to the power x times ln of x.
Yeah. I'm saying I like to.
Because I only ln of 2.
No, I only told you it's rule 6.
Yeah.
Oh, okay. Right. It's 2 to the power x times ln of 2. Well, understand this? Which rule you said you are? 6.
Yeah.
So this is rule 6 that I used to get that. Okay?
And I will use X.
Right, sorry. Sorry.
So used to X.
I'm so, yeah, that's the thing. So right? Okay. So you'll understand now where I am, right?
Yeah.
Okay. Now that we have this, you just apply the chain rule. dy over dx is equal to dy over du times du over dx. We know the value of dy over du, which is what here. We know the value of du over dx, which is this. So this will now become 2u times ln of 2 times minus 1, which is minus 2u times ln of 2. So this implies that dy over dx is equal to minus 2 to the power minus x times ln of 2. And we've derived 2 to the minus x using the chain rule. We all say together. Okay,
Yes, dear, I'm just thinking that we have to know these rules.
which rules?
These
All
15
these
rules?
rules.
No, they give you the.
They give us that.
They
Give
give the
us
table.
the-
They gave you right? You see when I showed you the rest of the table and I said it goes from 16 to 25. 16 to 25 is derived using the chain rule. So that first 15 rules is given to you. You use the chain rule to get the rest. Right? So you're always going to come up to a point where you're going to have it in terms of one variable. So you can use the table to get the rest. Right? So that's why the table doesn't go all the way up to 25 because of the chain rule. but they give you the chain rule on the table. Okay? And the table on the data sheet. Okay? And take a picture of this. Okay. Okay, you're okay then?
Yeah.
Okay, that's fine.
Okay, so if he asks you for y is equal to sine of 2x, derive it. They want dy over dx, right? Yes, we have a rule in 1 to 15 that says d over dx of sine of x is equal to cos of x. But is this sine of x?
No.
No, it's sine of 2x. So, which are the functions? What are the two functions here?
Sine
X and
Sine of x
and
and 2x. Okay? Because remember, it's this sine of 2x. Okay? So, we need to apply the chain rule. So, what would you do?
let's you but the function is called x.
What should be?
2x.
2x, right? So, you'd let u equal to 2x. You let u equal to the function that has the independent variable x. Okay? Then you derive this. So when you derive it, what would you write?
d over dx.
D over du.
I was trying to say it like how I say it here, right? You are deriving equation u with respect to x, right? Because that's what that means. You are deriving u with respect to x. Now, because you introduce d over dx here, you have to introduce it to the other side. Okay? So d over dx of 2 of x. Right? So it becomes du over dx equal to, this is a constant. So you can put it out. It can become 2 d over dx of x. So what that becomes?
2.
Becomes 1. So d u over dx is equal to 2. Cool. Right. Now, because we let u equal to 2x, our equation on the top became what? Y is equal to sine of u. Okay? Now I want you to derive that. How would you derive it? What would you write? After you write y is equal to sine of u, what would you write?
Equation y
What yeah?
with respect to u.
We are deriving
Equation
y with respect to u, because u is your independent variable. Because you introduce d over du on this end, you introduce it on this end, sine of u. So now you're left with dy over du equal to, now it's in terms of just one variable, just that variable. No negative signs, nothing. Okay? No to the powers, nothing. So what that becomes?
cos u.
Becomes cos of u.
Cos of u.
Oh yeah.
Yeah.
Cos.
Only 9.
Right? So now you apply your chain rule. Your chain rule says that dy over dx is equal to dy over du times du over dx. dy over du is
Cos u.
cos of u times du over dx 2. So this is 2 cos u, which implies that dy over dx is equal to 2 cos 2x. That's the derivative of sine of 2x. Different from 2 sine x. With me?
This one is just like after going all through all these things, it looks similar to like just changing this whole thing to rule 9.
Which is really.
Sin x is equal to cos x.
But see, it's different. because
Oh, yeah,
you wouldn't have
two
put
on
the
the
2,
side.
and the 2 would make a difference
Yeah,
in a
yeah.
calculation or something, right? So that's why it's important. Okay? You all got Let's do one more example, right? Just to further cement it. Now, you have y is equal to 3 log 5 times 4x. That's what they give you. They want to know dy over dx. They want to know the derivative of equation y with respect to x. Okay? Looking at this, what can we identify?
4x.
Okay, we can identify firstly that it's a function of a function. Which are the two functions?
It's 4x and log
And
5.
log 5, 4x.
Yeah, so remember when you write it, it'll be log this base number times that, right? So log times that inside bracket is one function. The other function is 4 of x. Okay? So they want you to derive it. How would you do it?
Say it right. Say it right.
Let you do
Equal to 4x.
Okay, why did you let u equal to 4x? Sir?
That's the function.
Because that's the function.
Okay, that's the function that has the independent variable x. So let u equal to 4x.
Yeah.
What will you do after that, Emma?
Sure. I don't know how you put it, but I don't know what's.
Okay, say it like how you would write it.
Okay, that's d over du times
d over du.
X.
Oh.
We do it.
or dx first. It's gonna be dx first times what was it, y.
Emma,
Hmm?
look at this equation. How would you derive this
Okay.
equation?
It's gonna be d over dx times u equals to d over dx times 4x.
Right. That equation, I'm only deriving that. I'm deriving u is equal to 4x.
Yeah.
Okay? So this will now become du over dx equal to the derivative of 4x. This is 4 d over dx of x. So du over dx is 4. Yes? Cool. Now, because I let u equal to 4x, my equation now reads as y is equal to 3 log 5 u. Okay? I did an example the other day when we had logs. Right? I did it the top corner of the board. What did I do when I had logs when I was trying to get into derivatives? When you see the log like that, what do?
Change to
Change
lin.
the length.
You change it to learn. How did I change it to learn?
Okay, let's see. It was. It
So,
was.
if you were given log of ax, to convert it to ln, it becomes ln of x over ln of a. Okay? So this would become what?
Ln of over ln of
So, okay, it will become 3 ln of u,
over ln of 5.
right? Now we need to derive this. Okay, before I write it further, just here, y is equal to 3 over 5 ln of 5 times ln of u. Can we agree on that? Because if I multiply the ln u into this, it's going to become 3 ln of u over ln of 5.
Yeah.
This whole thing here is a value, it's a number. You put it in your calculator, you will get a number, which makes it a what? A constant. Okay? Cool. Now I need to derive this. Eh? I'm deriving equation y with respect to u, because that's the term I have there. So dy over du is equal to d over du of 3 ln of 5 ln of u. Agreed?
Okay.
That's a constant, so we can take it out. So dy over du is equal to 3 ln of 5 d over du ln of u. Anybody confused? Okay. So what does this become? What is the derivative of ln of u? One over u, right? Which number is Kai? Rule number 7, right? So rule number 7, the derivative of ln of variable is 1 over that variable. Okay, so this would now become 3 ln of 5 times 1 over u. Okay, so your chain rule, now we have dy over du. So chain rule says that dy over dx is equal to dy over du times du over dx. Okay, substituting, we'll substitute 3 ln of 5 times 1 over u times 4. So that 4 will multiply by the 3, correct? So I'm left with 12 u times ln of 5. So the derivative of y with respect to x is equal to 12 over 4x ln of, and that is the derivative of 3 log 5 4x.
So why you never changed it ln of 5 to like a number?
Because then it's going to give you like point something something.
Okay.
So it's okay if you leave it like that. Okay, because remember ln of 5 will be a number, point, look, you're going to have a lot of numbers and then you're going to have 4x here as well. It's gonna look messy. Right? But, okay, do you all understand the concept of chain rule?
Yeah, no, I'm getting it. It's just that I changed it. Now looking back now, which rule do I need to fit in now?
Yeah.
But that's the thing,
It's
see,
in the formula sheet.
it's in the form. When you get it in terms of just that variable, whether it's A to Z, whichever alphabet, I don't care, right? As long as it's to that alphabet, go for it. You can go for it, right? Because if it's just like, even if it's x to the power, you can still do it because that's xn, x to the power n, which is rule number 1, right? If it's 2 times x, that 2 will come out because it's a constant. Okay? If it's x minus 1, you derive each term, right? You'll derive x, you'll derive minus 1. Minus 1 will disappear because it's a constant. So you'll just end up with 1. As long as you have x and x only, you're fine. Here x is not x only, it's 4 times x. That made it 4 times x in this. That made it a function of a function. Okay? So you'll understand chain rule, right?
Yeah.
All follow with me?
Yeah, sure.
Okay, cool. Right? So we've done 4 examples. Please, when you're learning about the chain rule, do more examples because they still do dy over d of the angle if y is equal to sec cubed of the angle. Okay? It's not bad. Okay? In that instance, you would let u equal to sec of the angle. Remember, sec to the 3 of the angle is sec of the angle cubed. Right? Remember that?
Yeah.
This here, sec that of the angle is the same thing as saying sec of the angle cubed. So you would have let u equal to sec of the angle, right? And your other function you would have ended up with u to the power 3. and you derive.
Okay.
Okay.
Can you write that down?
Must you want to
Can
do
you
that?
do this one? Do it.
Let's see, right? I've got all your job.
Yes.
You have y equal to sec cubed, right? That's the exact same thing as saying y is equal to sec of the angle cubed. Okay? It's not the angle cubed. It's this whole thing cubed. Sec is not just sec if it doesn't have an angle. Right? Sec is nothing if it doesn't have the angle. So it's sec of that angle. If this 3 was here and there was a bracket around it, that's the angle cubed. Okay. That's what we have. So the function of a function part is that we have a function that's equal to sec of the angle, and the other function is that bracket cubed. So in this instance here, you're gonna let u equal to your function that has the independent. They want you to work out, calculate the derivative of y with respect to theta.
Yeah.
Normally they asked us for the derivative of y with respect to x. So you let, okay, I'm gonna change my earlier statement, right? You're gonna let your u equal to the term that they have with respect to. Okay? Because remember the other ones, dy over dx is the derivative of y with respect to x. So you let u equal to the terms, the function that had x as your independent variable. Here they ask you to derive y with respect to theta. You're gonna let u equal to the function whose independent variable is theta. Theta's independent the function that has theta as the independent variable here is what? Sec of the angle, right? So let's u equal to sec of the angle. Understand? Right. Let u equal to sec of the angle. What will you do after that? You're deriving equation u with respect to theta. So d of u with respect to the angle is equal to d over the angle sec of the angle. With me, that?
Yeah.
Am I good? You're okay?
Yeah.
Okay. So this becomes du over d of the angle, which is equal to, what's the derivative of sec?
You know, what we do with the 3? That's how I.
That's my other function. If it helps, guys, try to write down the both functions. Then if you want to see it, right? So the functions here is, you can say f of x is equal to sec of the angle, and you can call another function. Okay, this is f of theta, and then the other function will be here, right? So they substituted sec for x. So that's the two functions. And then because you'll be able to identify it, like what you're looking at, okay? So du over d angle is equal to?
6 angle 10.
So it's sec theta times tan theta, right? That's the right. Now, because we let u equal to sec of the angle, your equation y now becomes u cubed. Agree?
Yeah.
Right. Now we're deriving equation y with respect to u. That will be equal to d over du times u cubed. Which rule is that? Rule 1, right? So d over du, dy over du is equal to,
3
so it will be 3
du
u to the power 3 minus 1. Yes, everybody knows that? So dy over du is equal to 3u squared. Okay, you all okay? You okay?
Oh, yeah.
Then it's like how, it's like how we had extra power n. It's just u to the power n now. Right. So applying the chain rule will look a bit different now because it will have the theta 4 wherever you would have x. Okay? So dy over d theta is equal to
dy over du
times du over
dx.
theta.
Okay.
Right? Because it's not looking at x, it's looking at theta. You understand that part, right?
Sure.
dy over du is 3u squared. Yes? And du over d theta is sec theta. Right? So, your dy over d theta is equal to 3 sec theta squared. Substitute sec there, and the whole portion is being squared. So I will say sec squared theta times sec theta tan theta, which can be written as 3 sec cubed theta tan. Yeah, okay. Huh?
Just became longer.
Yeah, sec cubed theta is this.
Yeah.
Okay? So,
At least they gave you the question. It's dy over d.
they tell you calculate that. So they want you to calculate equation y with respect to theta. So when you're writing your final answer, that equation must be equal to factors that have theta in it. Okay? Not x, theta. Right? So, okay, so you understand, I guess? Chain rule, right? So page 205, they tell you a shorter method of differentiating a function of a function. The substitution method becomes too lengthy, especially if we differentiate functions or functions or functions or functions. Right? If we have a function in a function in a function, it's going to become a lot. Right? If we examine the substitution method closely, we can compose rules which would significantly shorten the differentiation process. So what they're basically showing you is that they came up with a rule, and then they showed you how they came up with the rule or why the rule makes sense. Right? So if you look at rule 16, the derivative of f of x to the power n with respect to x, sorry. So you have f of x to the power n. For example, if you had x plus 1, or just if you had x plus 1 to the power 2, that would be equal to n times the function to the power n minus 1 times the derivative of f of x. That's their rule. So that is rule number 16. Okay? I'm just going to show you with one what they mean by that rule. Right? So if they told you 2x plus 6 to the power 6, right? They told you 2x, why was just 2x plus 1?
Plus 6.
2x plus 1 to the power 6.
The example.
Yeah.
2x plus 6.
2x plus 6 to the power 6.
Yeah.
Okay. The functions of a function. One function is 2x plus 6. The other function is that bracket to the power 6. So they told you that derivative of f of x to the power n is equal to n times f of x to the power n minus 1 times the derivative of f of x. So in this instance, your function 2x plus 6 is to the power n, which is 6. So using rule 16, this will now become, so this is y, right? dy over dx would now become n is 6 times your function, which is 2x plus 6 to the power 6 minus 1 times the derivative of the function d over dx of 2x plus 6. Okay? So this would now read as 6, okay, 6 into 2x plus 6 to the power 5 times, what's the derivative of this? Remember, you would derive each component. Yes?
Yeah.
Because remember, it's that. And if you derive 2x, what you left with?
Just
2 times
it's 2 times 2.
Must I show the working or?
It's gonna be 2
Okay.
times.
So remember, this is d over dx times 2 of x plus d over dx times 6. Okay? So when you derive this, it becomes, and then this here, 0.
Oh yeah.
Okay? Because it's x to the power 1. And then, no, it's x to the power 0, sorry. Okay? So x to the power 0 minus 1 is, no. See, the other thing is the same thing, isn't it? It's the derivative of other thing, the exact same thing.
The root 3 is the derivative of
Constant.
Is equal to
That's
0.
0.
Right.
Yeah.
Derivative of other than the exact same thing standing over there, let's say. But anyway, from your rules, derivative of a constant is 0. So the derivative of this equation is just 2. You're all with me, right?
Yeah.
So dy over dx is equal to 6 times 2x plus 6 to the power 5 times 2, which is 12 times 2x plus 6 to the power 5.
Let's say so the 2 becomes. We get the 2 from.
The 2 comes
The
out.
2 comes from here.
Yeah. Or comes out of the whole equation.
Yeah, we need to put it on the front.
Down
and then
here
we got
it comes
x
out
minus
and then
1.
the x
No,
is
x.
1
And then the whole thing
becomes
becomes.
1.
Oh yeah, this is a constant,
Yeah.
right?
Yeah, so that comes
So it's a
out.
constant time the x, the constant can come out.
Okay.
This here is just the derivative of a constant.
Yeah, you didn't show that step. Yeah.
Yeah. Okay, that's d over dx times k. This is d over dx times kx.
So the 6 just falls away.
Derivative of a constant is
The 0.
Okay.
okay. So that's how they came up with rule 16 using the chain method, right? And that's how you would apply rule number 16. Similarly, they came up with rule number 17, 18, 19, 20, 21, 22, 23, 24, 25. And you apply it like how you would apply rule 1 to 15. You will apply it like how you will apply that. So instead of doing the chain rule and breaking up each thing, your shorter method is looking in your rules to see which function looks like it. If we use chain method on that, the chain rule on that, we would have said let u equal to 2x plus 1. We would have solved. We would have said let, so we would have said if u is equal to 2x plus 1, y is equal to u to the power 6. We would have derived that. We would have multiplied it. And we would have still came out to 12 times 2x plus 6 to the power 5. So they shorten the method instead of you substituting one. Okay? Then they derive the rules. It's exactly like how we did the other day, rule 1 to 15. Okay? So that's what they basically did on page 206, 207, 208, 209, 210. Right? They derived the remaining rules from 16 to 25. And they came up with page 211, the summary of differentiation rules. That's what's important, right? Rule 1 to 15 you're already familiar with. Rule 16 to 25 is the additions of rules that came out using the chain rule. Rule 16 to 25 is rules for functions of functions. So far guys, everything I did today, you're with me.
Yes.
Just to practice it.
You have to, with differentiation guys, I'm gonna be dead honest with you all. The only thing you can do is practice. The more practice you do, the more you're able to identify rules easier, and you're also able to get the method in your head. Okay? Only thing you can do is practice. I can only teach it to you all. If you all choose to go home and actually do it and learn the method, practice it, then okay, that's the only way you get perfect at it. Okay? Because you can see from what we did, it's not difficult. There's nothing here that could trick you up. It's just practice. I don't expect you to remember it the first day I read, but by the third, fourth example, you knew what you were saying when you were saying it. Okay? So from rule 1 to 25, that's basically functions of a function. So you see like rule 18, they tell you d over dx cos of fx, right? So fx could have been 2x, it could have been 3x, it could have been minus 3x, it could be x to x squared, anything like that. How you would derive it, you would say minus sign of that function, so whatever f of x is, times the derivative of that function, and you would get your answer. Okay? Similarly for all others. That question that we did the other day, the one that earlier from the past year paper, we were supposed to use rule 23 and 24 to answer that portion of it. Okay? Because it's e to the power f of x. I took it as e to the power, just e to the power x. That's why I missed out the 2 or 3 terms that were supposed to be there. Okay? Because of the chain rule. Okay, guys? That was chain rule. Before I move on, does anybody have any questions? Is anybody confused about anything? Are we all okay?
It's a lot to take in, but it's only on my practice because it's not.
It's not difficult. You go, that's the chain rule. Chain rule is always the chain rule. Your method, you let u equal to the independent variable that they have in your equation. Like if they're looking at dy over dx, you let it equal to x. Substitute, derive, you get your answer. Okay? Now I'm moving on to page 214. Okay? Can I raise the board?
What was that, Sadia?
Yeah, let me just go to 16 there, right? It's not bad, it's easy. Okay, can I take it? Yes. Okay, I'm trying to change rule. And don't forget that log thing, right? So you're doing derivations of logs, convert it to natural logarithms, and then so, right? That's product rule. Okay. So the definition of the product rule. Okay. If u and v are functions of x and y, okay, and y is equal to u plus v, u times v, sorry. What?
Why are you confusing us?
Why am I confusing
You
you?
said if u and v are functions of x and y,
You and me.
Functions of x.
fx, then y is equal to y is equal to u.
Who said anything again? You. Who did anything? See, only numbers in my head, no English. The thing is very bad. Okay, sorry about that. If u and v are functions of x, you'll understand what that means.
Yeah.
Right? Not x and y, just x. And then I blame them, they should have put a full stop and said if y is equal to, right?
Okay.
So what they're basically saying is if you have equation u, right, and u is equal to 2x, u is a equation u is a function of x because x is your independent variable. Your u is dependent on the value of that. When we say the function, we say it's a function of the independent variable. So that equation u is a function of x. Okay? And if v, let's say that was equal to 3x, is a function of x, right? And the equation is y is equal to u times v. Then you introduce your product rule, right? Your product rule tells you that, so if y is equal to u times v, then dy over dx is equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. That is your product rule. Okay? Dy over dx, if you have an equation that u is times v, u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Another way of saying it is, if you have u times v, you keep one the same and you multiply it by the other derivative, plus you keep the other the same and you multiply by. So if this is my first part and my second part, right? How to use the formula? You keep the first part the same and you multiply it by the second part's derivative, plus the second part the same multiplied by the first part's derivative. That's what you do. Are you with me? Sure. Right. So that's basically what they say. Another notation is y is equal to f of x times g of x. They tell you f of x times g prime x. G prime x would be the derivative of g of x. It's the same thing that they got there, okay? But don't worry about it. They basically at the towards the bottom of 214, they give you the derivation of how they got to this formula. You all don't need to know that. You all need to know the formula and you'll need to know applications of the formula. So, rules without examples mean nothing. So, let's do examples. Okay? So, what's x squared and x cubed? Okay? So, example, y is equal to x squared times x cubed. Calculate dy over dx. Right? Let's use it. Okay, using the product rule first. Okay? Your u in this instance is what? X squared. Huh? Okay, u is x squared, right? And v is x cubed. Okay? The substitution method, right, is you derive, okay, so we said u is equal to x squared and v is equal to x cubed. Okay? So the derivative of u with respect to x, right, is equal to d over dx times x squared. The derivative of equation u with respect to the independent variable x is equal to, because I introduced d over dx on this side, I introduce it on the other side, is equal to d over dx of x squared.
Previously you were putting the u first and then you did this.
Well, I was showing you that, but yeah. Okay. Because remember this here is me adding d over dx on that side. I'm saying derivative of that equation. So now I'm saying the derivative of x squared with respect to x. Okay? So du, you'll see once you get used to it, you'll also start writing. I just break it up because I want you to see that I'm deriving equation u and then I go, okay? Over dx is equal to, what is the derivative of x squared? It's rule 1, what's rule 1 is?
N minus 1, so it's gonna be 2.
N times x to the power n minus 1.
Yeah.
So it's 2x.
Yeah.
Cool. So du over dx is equal to 2x. Here, derivative of v with respect to x is equal to d of dx. Another way of saying it is, remember I said the derivative of v with respect to x, I said it d.
Yeah.
This n is basically me substituting v.
I was on the act really.
This v, I mean this part here, is basically me substituting x cubed for that. Because I said v is equal to x cubed. Right? So that's what it basically is. Right? It's me deriving. Okay?
Okay.
Right. So dv over dx is equal to
3x.
3x.
3x squared.
Yeah,
right?
1.
3x squared. 3 minus 1. Now how about u, du, dv, everything. Right? Product rule states that dy over dx is equal to u times dv over dx plus v times du.
Right.
Okay.
Substitute. U is x squared. dv over dx
That's 2x.
is 3x squared.
dv over dx.
Yeah.
That was
With me.
yeah.
Plus v is x cubed. du over dx is
2x.
2x. Still with me.
Yeah.
This now becomes 3x to the power 4 plus 2x to the power 4.
No. Okay.
Okay? And this becomes. Do you understand?
Not 1. Yes.
Understand, right? Do you understand what I did? So this here is known as the substitution method. You know, like how we did for chain rule. Another method you could have done, which once you're comfortable, you'll be doing this, but I'm going to be doing this a bit more often because it's quicker to work with, right? See, your equation was y is equal to x squared times x cubed, right? And I said that that is u and that is v. My product rule formula says that dy over dx is equal to u times dv over dx plus v times du over dx. U is equal to x squared times, they want the derivative of v, equation v, with respect to x. So they want d over dx of,
Okay.
am I right?
Yeah.
I understand it, right? It's the same thing as that. Right? They want the derivative of equation v with respect to x. So where v was, I just substituted x cubed.
Okay.
Plus v is x cubed, and they want the derivative of u with respect to x. So they want derivative of u with respect to so this would be x squared. The derivative of x cubed is what? 3x squared, right? Plus x cubed, derivative of x squared is 2x. And you end up with 3x to the 4 plus 2x to the 4, which is 5x to the 4.
This one is shorter.
It is shorter, right? This is a bit longer, but because you're still learning how to do it, use it like this. When you're comfortable, do it like this. Because the only thing that could possibly mess you up here is not understanding the concept of what these things mean. Right? This is equation u, which is u is equal to 2x squared, right? Times the derivative of equation v with respect to x. So it's times the derivative, equation v is x cubed. So it's times the derivative of x cubed with respect to x. Yes? Same thing further on, right? Plus equation v, which is x cubed, times the derivative of equation u. Equation u is x squared. So where they are u, I can substitute x squared. So this is the derivative of x squared with respect to x. When you see it like this, one function, you just derive. They're telling you to derive x cubed. You used your rule, you got this. And then you get there. It looks a bit overwhelming, but it's an easier method, right? So, see? Oh. Right? If they didn't ask you to use the product rule, how would you have done it? Using just maths that you know.
So, that's the product rule.
See, this here is the product rule.
Yeah.
This is also the product rule, right? This was just the product rule using substitution. Sign up.
Yeah, I'll give you an exercise because the meeting will be about like 45 minutes to an hour.
Okay. They can do this. Right?
I could have just added those exponents.
Right. Because
Right,
remember,
x5.
x times 2 times x to the power 3, it's the same base, you add the exponents. Would be x to the power 5. You would have, so
five.
this here, without the product rule, right? Y would be equal to x2 times x cubed. Same bases, you add the indices. So that's x to the power 5. That's y is equal to. So dy over dx is equal to d over dx of x to the power 5. That thing is rule number 1, which would be 5x to the 4. No, that's our short differentiation. Eh? Obviously, it's easy for something like this, but when you have more complex equations, the principle is still the same, but to derive like this would be difficult because the math that you will need to do to multiply everything out and stuff makes it more difficult, right? But in the paper, they will ask you, given the equation y is equal to blah blah blah, use with the aid of the product rule, calculate dy over dx.
Okay. Are they telling you what to use?
Okay? Yeah, they tell you because you're going to learn the quotient rule. Now, the product rule, product of a number, right? Multiply. The product rule is for multiply. Quotient rule is for dividing.
Okay.
Yeah, I got that meeting now. So, please, guys.
It should be strong.
Chain rule. Do some examples on it. Remember, I told you there were still a few more examples that you could attempt, right? Do that. When you're comfortable with that and you understand, the main thing I need you to understand from this whole thing is these notations and what they mean. The derivative of y with respect to x. So it's the derivative of whatever y is equal to x squared. It's the derivative of x squared with respect to terms of x. So your answer must come out in terms of x. Okay, you're deriving the equation to end up with the variables of this. Okay? Once you get that concept, all of this becomes easy because it's just manipulation and substituting into the formula. Okay? But so far, are we confused about anything?
So this one is even easier than the other one. The
I'm
product
glad you
rule.
said easy, you know I'm hard now because a lot of people have problems with this, right? And these sections set the basis for your N5 maths. Because from here, N5 maths is more differentiation and integration. That's why I'm trying to get it to your, like, make you understand it. Okay? Because once you do this, if you get this here perfect, everything after this is easy. Okay? So I'm going to stop here and I'm going to go for the meeting. Chain rule, do more product rules. Okay, I did one example. You'll see there's more other examples I was going to do was there's only 3 examples. Okay, the 2x times e to the x, and then if you have the product rule for 3 factors on page 216. Okay, you can attempt that. It'll be more easier for you to understand now that you know this. And then they even give you some exercises you can attempt it. And then, okay, so I'll see you after that. I want to do the quotient rule today. I'll see, maybe I'll do some of it in science 10. And then I'll do a little bit science. Science by next week Tuesday, I'll finish off with science. And I'm done. Or next week Monday. Okay guys, I'll see you soon.